we talked about sets, we can talk about other elements that come from a set. Let me give you one example. In a class of 30 students, the instructor asks students to form groups of 5. Okay, so we have a class with 30 students. This is the class, and the size of the class is 30. And the instructor asks the students to form groups of 5 students in each. The first group, the second group, the third group, the fourth, the fifth, and the sixth. So this is group 1, group 2, group 3, group 4, group 5, and group 6. These groups are called subgroup of this set. So each group is called a subgroup of the set, which is the class of 30 students. So this is just a very easy example of definition of a subgroup. So note that with 30 students, we can form many subgroups. Let's work on the official terminology. We're going to talk about a universal set and the subsets for a set. Let me introduce this example and then talk about the official subsets. Suppose set S be the set including 1, 2, and 3. The cardinality of this set, or the size of this set, is it has only 3 distinct members. The question that you should be asking is, how many subsets do we have? Okay, very good. How many subsets we can construct here? The very first subset is the empty set. The very first subset is empty set. Wherever you go, whenever you have a set, the very first subset that you're going to introduce for a set is going to be the empty set. Empty set. The next subset that you're going to take are elements with only 1 members. So think about a class with 3 students. The instructor asks the students, hey guys, form subgroups. Okay. The very first student says, hey, I want to work individually. The second student says, hey, I'm going to work individually. The third student also says, I'm going to work individually. So the second possible subset is the set including the first student. The third possible subset is the set including the second student. The fourth subset is the set including the third student. Okay. What about student 1 and student 2 want to work together? What if a student, the first student and the third student want to work together? What if a student number 2 and student number 3, they want to work together? Yes, those are another scenarios. The fifth subset is the first student and the second student. The sixth subset is the first student and the third student. The seventh subset is the second student and the third student want to work together. And finally, the last subset, the eighth, or just the last subset, is all of those students want to work together in one group. So how many possibilities do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8, we have 8 possible subsets for set S 1, 2, 3. Okay. So I expect you to ask, do you have any formula to help us identify the numbers of subsets? Luckily for us, you just need to take 2 and raise it to the size of the set. This gives you the number of possible subsets for sets S. Okay, let me double check this formula for this set. N of S is 3, am I right? So 2 to power 3, 2 raised to the third. Guys, this is not 6. It says I'm multiplying 2 3 times. The exponent 3 shows the repetition in multiplication of the base. Base is repeated 3 times. 2 times 2 is 4. 4 times 2 is 8. So we expect a set with 3 members have 8 subsets. We actually calculated all of those subsets and wrote them down here. Empty set, set with first student, set with only second student, set with only the third student. You might have the first student and second student want to work together. The first student and the third student want to work together. The second student and third student want to work together, or the class of 3 students say, hey, we just want to work together all as a group. Or you might have students who are saying, hey, we are not interested in doing any group activity. So the very first set is going to be an empty set. If you take all of these together and form a set, we call it the power set of S. The power set of S, which is denoted by P of S. P of S is the power set of S. What are you going to do? You're going to take all of these subsets and write them in a set. Empty set, set including 1, set including 2, set including 3, set including 1 and 2, set including 1 and 3, set including 2 and 3, and the last set is equal to S itself. Set including 1, 2, and 3. So this guy, P of S, is called the power set of S. We're going to list each of these subsets as members of this new set that we call the power set of S. How many members does it have? Okay. 1, 2, 3, 4, 5, 6, 7, and 8. As we expect, this set has 8 members. The power set of S has exactly 8 members.